Welcome to a lesson on quantitative literacy. Playing with formulas is what we're going to do today. So recall that BAC formula that we messed around with before. If we know the number of drinks someone had and their weight and their gender, we can find their BAC at a given time after they are done drinking. So I just want to explore that a little bit in some different ways. So let's consider a male, 150 pounds. If I take into consideration this fraction over here, ignoring the number of drinks for a minute, I have that 2.84 on the top, I have 150 pound and the gender factor on the bottom, and if I plug that into my calculator and clean it up, I get about 0.028, so 28 thousandths. Plugging that back in, then the BAC is approximately negative 0.15 t plus this factor times the number of drinks that the person has. So then I can explore over time and drinks what this person's BAC is. Now suppose I want to take it a slightly different direction, and I'm kind of curious over a certain amount of time, like maybe 3 hours, how many drinks would this person have to have so that their BAC was about 0.06, so under the legal limit for operating a motor vehicle. So I can plug those values in, so that's going to give me, switch colors, 0.06 equals negative 0.015 times 3 plus 0.028 times the number of drinks. And so then I could solve this for the number of drinks. So let's whip out a calculator and do that. So let's see, what do we got there? We want to know what is 3 times, so we have 3 hours later, that 0.015, and that gives us 0.045. So now I have 0.06 equals negative 0.045 plus that 0.028 times n. Now I can't add these two numbers together because I have a multiplication here, and order of operations says you have to multiply before you can add, but I can't multiply because I don't know what n is. So that means I need to take this negative 0.045 to the other side. So since it's being added and it's a negative, I'm going to add, oops, I meant to switch color there, excuse me. I need to add, there we go, 0.045 to this side and to this side. And I don't think I need a calculator for that. On the left side, when I add those two together, we get 0, 10, 5. So we get 0.105. And on the other side, well, I have a negative number and its positive version, and those two add up to 0. 0 plus something is itself. So over on this side, I'm just going to have 0.028 times n. And to break that multiplication, I'm going to divide that 0.028 to the other side. So let's do that. So dividing by 0.028 on that side. Now I definitely want a calculator. I'd rather not do that on paper or in my head. What is that division? And so that is going to tell me what n is once I whip out my calculator. And hopefully you're quicker on the draw than me with your calculator. And a spreadsheet wouldn't be bad here either, would it? Let's see, what do we got? Clear 0.105 divided by 0.028, and my calculator says 3.75. So 3.75. So that means if this person had 3 drinks, they would be under that 0.06. If they had 4 drinks, they'd be just over that 0.06 3 hours later. And if they had exactly 3 3 3/4 standard drinks, should be right at 0.06 for their BAC. after 3 hours. Now suppose we would just want to explore other ones, like when would they be 0.7, when would they be 0.8, when would they be 0.2? So then we're going to have to just plug in and solve, plug in and solve, plug in and solve. So in some cases it makes sense to take the equation and solve ahead of time. So we're going to take this equation right here and solve for n ahead of time, and then we can plug in any numbers we want easy, and we don't have to go through all these steps all the time. So let's give that a shot. So we're starting with b equals negative 0.015 times time plus 0.028 times number of drinks. And the procedure is the same one as before. The first step was to add this number to the other side, and the t is attached to it. They are connected and inseparable at the moment. So I have a negative version and a positive version. Those are going to add up to 0, but I also have to keep it balanced by doing that on this side too. 0.15t. Now these are different variables, so that means they're not like terms. So on the left side, the best I can say is I have b plus 0.015t. Can't really clean that up any further. On the other side, however, this does clean up. That becomes a 0. So that adds up to 0. And this is left behind, 0.028n. And again, I'm trying to solve for n here, so I'm going to break that multiplication by dividing. So then dividing by 0.028 on this side. And on this side, I'm going to get a number divided by itself as 1. 1 times n will give me n. On this side, I've got to make a big fraction bar because I have to divide the whole thing by 0.028. And so cleaning that up, really the only thing I can clean up is this side. 1 times n is n. Oops, wrong color. And on the other side, I could leave it like that. That's okay. I could plug something like that into my calculator. And I'll double check in just a second. Oops, missed a 0 there, didn't I? Okay. Other options, some of you might be dying to divide those two numbers, and you could. However, you got to consider that the 0.028 is dividing both the b and that. So if you wanted to do this division right there of those decimals, you'd have to also include b. So another way to write this answer would be b divided by 0.028 and that 0.015t divided by 0.028. That kind of adds another complication, because if I carry out this division, it's probably going to lead to a crazy decimal. So let's take a look on the calculator, which leads to more rounding, which leads to future rounding errors. So I've got 0.015 divided by 0.028. And it's this long decimal that probably keeps going if the calculator had room. So, you know, I don't really like that, so I'm not going to do that. But this is another valid version of the equation. So this, and that, by the way, that's equal to n still. So this would be a possible answer. This is a possible answer. You could carry out that division like I did and write down that decimal. That would be another possible answer. I like this one right here because it's less work. And it actually looks a little nicer. And usually we want a simplified equation, and a lot of times in math I judge simplified by which one uses less ink. So I'm pretty sure this top one uses less ink than that one. If you carry out that division, that's questionable as to whether it uses less ink. Well, let's test to see if we did this right. So earlier we looked at what? A BAC of 0.06, 3 hours later. So we're going to just whip out our calculator and plug in 0.06 there and 3 there and see if we get the same answer. So on my calculator, I'm going to start off with parentheses for that crazy numerator, and it's 0.06 we were putting the BAC at, and then I want to add 0.015 times 3. And then I want to close the numerator and divide by 0.028. And I should get that 3.75 I got before. So just testing to see if that formula worked the way I thought it did based on my previous work. So now I have a formula where somebody can say, hey, we are looking for a BAC of 0.03, and we're looking for 4 hours later, how many drinks might one have to have? And we just plug in and find the answer. So, for example, let's test that out. Parentheses for the numerator, 0.03 for the blood alcohol content, our constant of 0.015, and let's say we're going to go, I don't know, 4 hours later instead, and then divide by that 0.028. So if we wanted someone to have a BAC 4 hours later of 0.03, then that means they could have 3 drinks, but really not much more than that. Otherwise, they'd be over that 0.03 4 hours later. So we have another way to explore by solving an equation. So playing with formulas is the theme here. Let's look at another example. SAT scores. So that's a college entrance exam at a lot of schools. Some of you may have taken it. Average SAT score is about 1,000. It depends kind of on the year, but let's just call it 1,000. So notice that's the middle of my graph here. And the average spread, which is also called standard deviation, let's write that up here. Standard deviation, okay, is a measure of average spread, just like the mean or the average is a measure of the middle, is about 200 for SAT scores. They calculate the average spread. It's kind of complicated, but one way to look at it is about 68% of people that take the SAT should be within 200 points of the average. So if the average is 100, 200 points below would be a score of 800, 200 points above would be a score of 1,200, and the College Board expects about 68% of people to fall within that spread right there. Another way to talk about that spread and standard deviation is an idea called z-scores. And what a z-score measures is the number of standard deviations someone is from the mean. So this calculation right here is called a z-score. And all a z-score does is it counts the number of standard deviations. And standard deviation is usually given a special symbol, and it's that weird symbol up here. It's called sigma. So the z-score counts the number of standard deviations from average, from the mean. So just for example, just looking at this graph, I have 2 scales. I have x, which is my SAT score, and I have z underneath that, which is a count of standard deviations. So if somebody took the SAT and they scored a 1,400, and the standard deviation is believed to be 200, then they scored 2 standard deviations above the mean. And that's what this formula counts here. So if we claim somebody's SAT score is 1,400, to figure out their z-score, I would plug into this formula. So I would take their score of 1,400. From it, I would subtract the average of 1,000, and then I would divide by the standard deviation. So I want to know how many groups of 200 are in between their score and the distance to the mean. So 1,400 minus 100 is 400. 400 divided by 200 is 2, which is the z-score that goes along with 1,400. So oftentimes when you take a z-score, you'll get things like your percentile and your z-score, which compares you to other people with respect to spread that took the SAT that year or other years. And we can use that instead of calculating a z-score. If you were given the z-score and you wanted to know what score went with that, we could calculate that too. So we're going to take this z-score formula and we're going to solve for x, the SAT score. And this goes for a lot of different things. It doesn't just work on SATs. So it's a very useful formula in statistics. So those of you who are going to take statistics in the future, you'll see this. So I've got z equals x minus, the average is often given this symbol right here, which is called mu. It's a funky Greek letter. It's kind of a cross between an M and a U. divided by sigma, which is the standard deviation. So this mu symbol, that's the mean of the situation, the average. And that symbol called sigma is the standard deviation, which is the average spread, or one measure of average spread of the data. Because some data is more spread out than others. Some's tightly packed, and again, you'll look at that in future math classes. So I want to solve this for x right here. So if I knew what x was, I would first subtract the mean and then divide by the standard deviation. So to solve, I have to unwrap all of that. So I have to get rid of the last thing first. So I'm going to get rid of the standard deviation. So again, I'm trying to solve for x. So sigma has to go first. So that means I have to multiply both sides by that crazy sigma. So I get sigma times z on this side, and on the other side I get x minus mu. And then I just have to undo that minus mu, so then I can add that to both sides. So then we'll add mu to this side, and we'll add mu to that side. Now, since all these variables are different, there's no like terms here. So the best I can say on the left is I have sigma times z plus mu, and that gives me x. Okay, so this says take the number of standard deviations times the standard deviation and add on mu. So example, just to test that out based on my graph over there, if the standard deviation is 200 and the average is 1,000, and somebody has a z-score of, let's say, -2, then this formula says their actual score would be 200 times -2 plus the mean, 1,000. So that's going to be -400 plus 1,000, which is 600. So that means they actually scored 600 if they were 2 standard deviations below, that's the negative, the average. And so again, this was the formula I was trying to solve for. So instead of z equals, I have a formula that says x equals, and let's highlight that sucker. That's my highlighter. Going back, we can see that if I am 1, 2 standard deviations below average, that should go with a score of 600. Okay, so another example of solving a complicated formula. All right, one more example and we're out of here. Simple interest. So this right here, the PRT, you might have seen before, and that's usually what we talk about with simple interest, but sometimes we can extend that a little bit. So the interest amount is equal to the starting amount, sometimes called the principal or present value, times the percentage rate times the amount of time that goes by. And if we take that interest and we combine it with the amount we started with, then we get this new amount A. So A is what's called the future value, okay, the new amount in the account, or the new amount that you have. So let's suppose we started with $100 and we have a 5% interest rate for 2 years. The interest rate in general R is usually what we call an annual percentage rate, an APR. So we need to pay attention to the time that goes with the rate. So that would be in years, since it's an APR. So then I'm plugging into my formula, right? My P, my starting value is 100, and then that's what I start with. And I'm going to get some interest. To find the interest, I take the starting value and then multiply by the interest rate and the amount of time. And then I can add that back on to get a new total. So whipping out my calculator here. My interest is my starting amount times my interest rate as a decimal times the amount of time that goes by, 2 years. So that's going to give me $10 more. So this part right here, switch colors, is $10. And then I add that back on to my $100. And that's going to give me a new amount of $110. Applying that formula again, let's say I have $200 to start with, and I get 2% interest from the savings account. And simple interest means they're not giving you interest every year. They only give it to you at the end of whatever time they say. So it's just a one lump sum. Okay, so that's different than compound interest, which we'll talk about later. So for this, I would take my 2% for 3 years to get my interest amount, and then add that back on. So let's ask my calculator what it thinks about that. So I have my $250 times my 2% interest times my, was this one 3 years? Yeah, 3 years. I get $15 in interest at the end of 3 years. And you might be thinking, man, 2%, that sucks. Well, interest rates have been really low since the recession back in 2008. And so if you get 2% on a savings account, you're doing pretty damn good. Generally, they're like 0.5%. So interest rates still suck. Adding those together, I get, what's $265? I think we can do that without a calculator. Now, notice that each time I have to take that amount, do the calculation, add it back on. So it turns out there's a slightly easier way to do this. If you notice that we have this same amount here and here each time, here and here. And up above, pretty similar, we have that amount here and here. So slightly different version of this will make a little more sense if I just clean it up a little bit. So let me try on the next page, and hopefully this makes sense. So our equation, P, no, wrong one, A equals P plus PRT. I'm going to simplify this just a touch. So, and then I'll do it in a more general way. Let's just suppose that R is 10%, I wish, and T, for simplicity, is 1 year. And remember, when we work with interest, we have to change that percentage to a real number. So 10% as a real number would be 0.1. So plugging that stuff into my formula, I get A equals P plus P times 0.1 times 1. Okay, well, 0.1 times 1 is 0.1. And oftentimes with variables, instead of writing P times 0.1, we write 0.1 times P. So I'm going to write this again. A equals P plus 0.1 P. Now, another observation I can make. How many P's do I have here? Well, there's one of them. Okay, well, okay, let's write that down. So I have 1 P there, and I have 1/10 of a P there. So altogether, how many P's I have? Well, I believe I have 1 and 1/10 P's. Right? I have one of them, I have a part of one, altogether I have 1.1 P's. This idea is called adding like terms, right? You might have seen that in a math class before. If you have something like x plus 2x, well, 1x and 2x would be 3x's. If you had x plus 1/2 of an x, then you would have 1 and 1/2. It's supposed to be a 5, there we go, x's. And I'm just doing the same thing with p. I have 1 p, plus I have 1/10 of a p, so altogether I have 1 and 1/10 p's. Cool. So now I have a quicker way to come up with these answers. So if I look back here, the previous page, I could say my amount would be equal to, let's use a different color, I'll switch to green here, A, let's see, if we take 2 times 0.5, that gives me 0.1, that's kind of a nice coincidence, then I will have my $100, oh no, I just want to use that other formula I had, which would be 1.1 times P, and my P here is $100. So what happens if I take 1.1 times 100? Some of you might be able to see that in your head. 1.1 times 100 is $110, which is what we calculated, what I call the long way. Doing a similar thing down here, I have to first clean up this right here. So 3 times 2% would be 6%. So instead of my 1% here, sorry, 10%, I'm going to have a 6% there. Okay. So where am I? Back here. this right here should be, in the cleaned up formula, 1.06 times p. So 1p plus 6% of p should give me that. And if I test that on my calculator, 1.06 times 250, yeah, 265. All right, so last thing, we're going to put all that together in a new page. So starting with A equals P plus, P times R times T. What we can do is what's called factor out the P here and here. Now keep in mind I have one P right there, so when I factor P from itself, I'm going to have a 1 left behind. Another thing to think about with factoring is like dividing. And so it works like this. If you think you can factor something out, and I think I can on the right, write down what you're factoring out and then put parentheses. And then it's as if you divided by what you factored out. So what's P divided by P? Well, it is 1. What's PRT divided by P? Well, that would just be the RT part. So that is a new version of this formula. Now, the nice version of this formula right here is if somebody told me that they want to have $500, whoa, that's supposed to be there we go, $500 in 2 years, and they got a wicked good deal on a savings account. Their R is 5%, which would be 0.05. We can then predict how much they should invest. So how much should they invest? And what they invest, that is our P, our starting point. So basically, how much should I invest says solve for P. And I can do that pretty easy here because P is simply connected to this other stuff by multiplication. And to break multiplication, we just divide. So that means I have to divide this parentheses to the other side. And what that's going to give me is that P will equal A divided by that crazy parentheses, 1 plus RT. And so this is a formula here that will find an initial investment if you know what you want to end up with. So let's test it out in a couple of ways. So plugging these numbers into my calculator, into this crazy formula, I'll have to use parentheses carefully. We want to end up with $500. And we're going to divide by parentheses 1 plus our rate times our time. And our rate was going to be 5% in 2 years. So that means I want to take my 0.05 times 2 years. Right. Yeah. And then I hit enter. And that says I should invest about $454 and, if I round, 55 cents. So $454.55. So for this information, 500 divided by 1 plus 0.05 times 2, I get about 454.55. And to double check, we could go plug back into the original formula and see what happens. So if we plug in 454.55 and add on the interest, we should get back about 500. So let's try that. Clear. So applying this formula right here to double check, 454.55 plus that same 454.55 times that 5% interest rate we got lucky to get, times 2 years, I hope to get about $500 back. Now, since I had to round to this number over here, I'm getting about $500 here. Notice I had to round up a little bit for that one, so we're a little over 500. We did it. Okay. And the key to solving the equation this time was the idea of factoring. And factoring is related to what's called the distributive property. Ooh. Okay. So just note the distributive property is something like if you have 2 times x plus 3, you get to take that 2 and distribute it through. So you could also say instead this is the same as 2x plus 6. Factoring is reversing the distributive property. So factor is kind of undistribute. That's supposed to be a D right there. So if I started with something like 2x plus 6 and someone said to factor that, I would say, well, let's see, is there a common multiple here and here? And I could say, well, yeah, 2 times x is that, and then 6 is 2 times 3, so they have a common factor of 2, and I can pull that 2 out. Remember, factoring is like dividing, so if I take 2x and divide by 2, I leave an x behind, and if I take a 6 divided by 2, I get a 3 behind. So factoring is undistributing. All right, that's it for now. Take care, do good math. I'll see you in the future.